What's up, YouTube? Mr. King coming at you live from the 209. Here are the questions for the day. Please pause this video now and answer them. Next, here's some announcements. Our first exam will be next week. And also note, we have another 3-day weekend coming up. Today, what you should be able to do is observe how humans power their homes, their cities, and our bodies. And then you're going to create a policy to bring renewable energy to the world. If you haven't heard of the term renewable energy, renewable means you can use it again and again. So like electricity, that's really easy for us to keep using again and again. Whereas like gasoline, like our gasoline powered cars, once we burn that gasoline, we're not going to get that gasoline back. Which is why California put a ban on non-electric cars in 2035. Okay. Once you're all ready, I want you to think about the law of conservation. So that was a hint for number 4. Number 3, basically energy and matter. So everything in this universe, you can't create new stuff and you can't destroy old stuff. Like even just burning something, like burning this pen. Like this pen will not go away. All of the atoms in this pen will just go into the air now if I burned it. So you can't just destroy and create new stuff. You can only change it around. Like the anime Full Metal Alchemist, basically the idea is you can make something, but you have to take something away from it. Like Edward here made this bird, but he had to use the wood from the floor to make it. So the bird didn't come out of nowhere. He had to use something from the earth. That's the idea behind law of conservation. We're going to be practicing it today in this PHET. So if you go to Google Classroom, classwork, and then Tuesday, energy PHET simulation, click on it. Okay. The link is right here. And then once you click on the link and go to it, click play, and then click on the systems option right here. So systems will be on the right. And then you're going to be going back and forth between the worksheet and this thing. So first, I'm just going to show you how to use it. Click on the energy symbols. So now it'll show you the 5 different types of energy here. The white E's are mechanical, the blue E's are electrical, red is thermal, yellow is light, and green is chemical. And basically, to get it to work, we have a girl riding a bike here that is hooked up to this generator, which is a wheel or a turbine. And then we have some wires that lead into this water heater. This water heater is like something that will heat your water before you shower. To get the system to start, make her start pedaling by moving the bar. And then the chemical energy in a body will go to mechanical energy. That will rotate the wheel, which will convert into electrical engineering and electrical energy in the wires. And then that electricity will heat this water. And then it'll go back to thermal energy. And you may notice eventually this girl's going to get tired and you have to give her some more energy by feeding her. Okay. So first question, which energy sources can cause the turbine to spin? So there are 4 different options. Will the bicycle make it spin? Will the water faucet or the sink make it spin? Will the sun make it spin? And then will this kettle make it spin? That's number 1. Tell me which of these 4 will cause the turbine to work or the generator to spin. Number 2, what causes the solar panels to generate energy? This one you may already know because we're in California. So if you click on the solar panel, which of these 4 will work to cause the solar panel to go? Yep, try and figure it out. What will make the solar panel work? All right, number 3, which energy outputs objects work with the turbine? So what that's asking on this side, let's change it back to turbine and back with the bike. Or let's try the faucet now. So as you can see, the mechanical energy from the water gets converted into electricity that will heat the water. But over here, you can change it. Instead of having to go into your water heater, you can have it go to a light bulb or a fluorescent light bulb or a fan. So number 2 is just asking, of these 4 options, which one will the turbine work for? Will it work for all of them or just some of them? So that's number 3. Number 4, do the same thing, but for the solar panel. Will the solar panel work for the fan? Will it work to power your light bulb? And then will it work to power up your water heater? Yep, that is number 4. And then scroll down. Now I just want you to play around with the different things. Is there a little energy or a lot of energy when the faucet's on high? So if you go back to the sink or the faucet and change the wheel, to put the faucet on high, you just put that knob all the way out. How much energy is made when it's on high versus when it's on low, that little stream. And then try it when there are clouds for the sun and the solar panel. How much energy do you get when the sky is clear versus when there are clouds? How much energy is going to be made? And do the same thing for heat on the kettle. How much energy do you make when the heat's all the way up? Is that a lot of energy or a little? What about when the heat's down? How much energy are you getting? Okay. Last thing, do it for her when she's really pedaling fast versus when she's going slow. Okay. Then number 6, try and think, why do you need to keep feeding her? Why do you need to keep giving her energy? Hint, think about, why can't she just pedal all day? Hint, like the law of conservation of energy states that energy cannot be created or destroyed, only changed. So where must her energy come from? That's what I'm trying to get at for number 6. Number 7, you can just look up, what does the law of conservation of energy state? And then 8, we have some fill in the blank. For number 8, turbine moved by steam from medium heat with a water heater. So when you're at number 8, change it to the water heater and put the heat all the way up. For this one, I'm just asking you to fill in the blank. Tell me, what are the different types of energy that are working here? What kind of energy comes from the fire? What kind of energy comes from the steam? And then what kind of energy goes into the wires? And then what kind of energy goes into the water? Those are all the blanks. This one is just asking, what's the other type of energy that's getting released from the kettle? You'll notice that there are 2 different types of energy being released from the kettle. Just give me the other one that you didn't talk about. All right. Number 9, switch out the fluorescent curly one, the fluorescent bulb with the incandescent bulb, and observe the energy output. What do you notice about the difference in the energy of these 2 bulbs? So this one, just change it. How much energy does this one produce? How much energy do you get out of this round incandescent bulb versus how much energy do you get out of this one? Out of this fluorescent bulb. Just watch the E's carefully. Which one is letting more out over time? Then 10, in your opinion, which light bulb is more efficient? Or which one uses less energy? Look closely, which one will light up faster, and which one needs less energy to start, to get going? Is it the round one, the incandescent bulb, or the fluorescent one? Okay. 11. In the space below, explain why the simulation is a good way to illustrate the law of conservation of energy. So this one, just tell me, why does the simulation show you that energy cannot be created or destroyed, only changed. And then 12 is a little bit more difficult. You are the chief scientist for the United Nations, and you are in charge of installing 6 million solar panels across the world. Based on the solar panel simulation, what are 2 things you need to power a solar panel? So think about when you have the solar panel up, what do you need to get this to work? And then think, do you want to have clouds or do you want to have no clouds? That's my hint for the last one. And then where do you think, what continent? If you're not sure what a continent is, look it up. If you can spell right, look up, or you can look up the 7 continents to learn what are the different types of continents. And now you're in charge of deciding where should all the solar panels go, and then why. Should we put the solar panels in North America, South America, Europe, Africa, Asia, Australia, or Antarctica? What do you think? And then tell me why you put those solar panels there. That is the last thing. Once you do that, you're all good to go. Please take this attendance survey, and then you're all good. Thank you everyone for watching me the whole time. Bye. Have a good night.